Good morning class. In the last section we were discussing about the factors affecting conductivity or conductivity of an electrolyte, and we discussed about two factors, that is solute-solute interaction and solute-solvent interaction. In the third segment or in the third topic we have to discuss about the third factor, that is solvent-solvent interaction, or interaction can be explained in another term, that is a bonding or a force which exists between solvent particles or solvent molecules. So, in case of solvent-solvent interaction, when the interaction between solvent particles are more, that is the solvent particles are held by strong forces, and when the interaction between solvent particles are more, that means there will be lesser dissociation of ions, and lesser will be the dissociation of ion, that means lesser will be the amount of current, and lesser is the amount of current, that means lesser is the conductivity. So, if the solvent particles or solvent molecules are held by strong forces or the interactions between them are more strong, that means lesser is the formation of ions, lesser is the amount of current, and at last lesser is the amount of conductivity or lesser is the conductivity. So, these are the factors. So, in short we can say solvent-solvent interaction is inversely proportional to conductivity. It is inversely proportional to conductivity, because more is the interaction between solvent particles or solvent molecules, that means the interactions are strong, the interactions will not be broken easily, that means lesser is the formation of ion or lesser will be the amount of ions, lesser is the amount of current, and at last lesser is the amount of conductivity or lesser will be the conductivity of the medium. So, in short we can say solvent-solvent interaction or solvent-solvent bonding is inversely proportional to conductivity. So, more is the strong interaction, more the strong forces, the forces existing between solvent particles will be more, that means they will not be broken easily, that means lesser will be the formation of ions, lesser will be the current, at last lesser will be the conductivity. So, in short it can be said that solvent-solvent interaction is inversely proportional to conductivity. Next would be fourth point, that is temperature. Next is the fourth point, that is temperature. Fourth one, temperature. So, temperature is directly proportional to conductivity. Temperature is directly proportional to conductivity. Temperature is directly proportional to conductivity. It is because more is the temperature, more is the formation of ions, more is the formation of ion, that means more will be the value of current, and since more will be the value of current, that means more will be the conductivity. So, in short it can be said that temperature is directly proportional to conductivity, because when the temperature will increase, the kinetic energy of the molecules will increase, that means there will be the more collisions between the molecules of the given solute or solvent, and hence there will be more ionization. So, more will be the value of ions, more will be the value of current, and hence more will be the conductivity. So, in short it can be said that temperature is directly proportional to conductivity. And the last topic is the fifth one, that is nature and concentration of electrolyte. Nature and concentration of electrolyte. This is the fifth point and the last point or the last factor which governs the conductivity of an electrolytic medium. So, the last topic is nature and conductivity of electrolyte or concentration of electrolyte. So, with regard to nature, it can be said that The nature of an electrolyte can be either polar or it can be non-polar. And related to concentration, it can be said that an electrolyte can be either concentrated or it can be either dilute. It can be of the any form. It can be polar, non-polar, concentrated or dilute. So, since we are knowing about a general fact that like dissolves like, that means a polar molecule or a polar solvent is always immiscible in polar medium and non-polar is miscible in non-polar medium. So, if there is a polar electrolyte, that means the conductivity of a polar electrolyte or a polar electrolyte has a more conductivity. That means it is directly proportional to conductivity. That means more is the polarity, more will be the conductivity of the medium, and the conductivity of a non-polar compound is inversely proportional to conductivity. More is the non-polarity, that means lesser will be the conductivity of the solution. It is because if it is polar, then it will have two positive ends, one will be the positive end and the other will be the negative end. Because of having polar ends, that means it is easily ionizable in a given medium, and hence more will be the formation of ions, more will be the value of current and more will be the value of conductivity. If it is a non-polar molecule, that means positive and negative ends won't be formed. If it does not have positive and negative ends, that means lesser will be the formation of ions, lesser will be the value of current and hence lesser will be the value of conductivity. So, more will be the value of non-polarity in the molecule, lesser will be the value of conductivity. Now, related to concentration, we can say that the concentration can either be concentrated or it can be dilute, solution can be. Concentrated can be explained as when the value of solute is greater than solvent. So, it is known as concentrated, and when the solute, the amount of solute is less than solvent, then it is known as dilute. So, if we have a concentrated solution has always a greater conductivity as compared to dilute. Concentrated solution always has a lower conductivity as compared to dilute solution, because dilute solution has a higher conductivity. So, these are the two factors. The concentration can either be concentrated or it can be dilute. Concentrated solution means that the amount of solute is greater than solvent, and dilute solution means the amount of solute is less than solvent. If the solution is concentrated, that means solute is greater than solvent, then it will always have a lower conductivity. It has a lower conductivity because the concentration of solute is greater than solvent. If the concentration of solute is greater than solvent, that means there will be less ionization, ions won't be formed easily. Because of the lesser formation of ions, the current will also be less, because more will be the ions, more will be the current, and lesser are the ions, lesser will be the current. So, since it has a lower number of ions, lesser will be the current and hence lesser will be the conductivity. Similarly, when we have a dilute solution, because the concentration of solvent is greater than solute, that means more will be the formation of ion, more will be the current and hence greater will be the conductivity. So, these are the 5 factors which govern the conductivity of an electrolytic solution. The 5 factors were, the first factor was solvent-solute interaction, then the second factor was solute-solvent interaction, then the third factor was solvent-solvent interaction, fourth factor is temperature, and the fifth factor is nature and concentration of electrolyte. The first factor was solute-solute interaction. More is the interaction between solute molecules, lesser will be the formation of ions, lesser will be the current and lesser will be the conductivity. Then the second factor was solute-solvent interaction. More is the interaction between solute particles and solvent particles, lesser will be the formation of ion, lesser will be the current and hence lesser will be the conductivity. And the third point was interaction between solvent particles. More is the interaction between solvent particles, lesser will be the formation of ions, because bonds won't be broken easily, and hence lesser will be the current, and at last lesser will be the conductivity. The fourth point was temperature. Temperature is directly proportional to conductivity, and conductivity means the ability to conduct electricity. More is the ability to conduct electricity, more will be the conductivity. So, temperature is directly proportional to conductivity, because when temperature increases, the kinetic energy of the molecules increases, and hence the random collision between molecules also increases. So, when temperature increases, there are formation of more will be the number of ions, more will be the value of current, and at last more will be the conductivity. And last point is nature and concentration of electrolyte. The nature of electrolyte refers to whether it is polar or non-polar. More will be the polarity, more will be the conductivity, and lesser is the polarity, lesser will be the conductivity. And concentration, concentration refers to whether it is concentrated or dilute. Concentrated means that the amount of solute is greater than solvent. More is the concentrated, more will be the solution concentrated. That means solute is greater than solvent, ions won't be formed easily, lesser will be the value of ions, and hence lesser will be the conductivity. And dilute, if there is a dilute solution, the amount of solute is lesser than solvent. Since the amount of solute is lesser than solvent, that means more will be the formation of ions, more will be the current, and hence more will be the conductivity. So, these were the factors which affect the conductivity of an electrolytic solution. So, next we shall discuss about some of the factors which are, or some of the terms which are related to the term of electrochemistry. Among them, the some factors are resistance, resistivity, conductance, conductivity. So, let us discuss what are these terms. Among these, the first term is related to resistance. The first term is resistance. And in resistance, we have to discuss a law called Ohm's law. Now, what does Ohm's law? Let us see. Ohm's law states that if the physical conditions of an electrolytic medium remains constant, Ohm's law, Ohm's law, just start करना है उसको.